Sampling design. What is sampling design? Sampling is a fundamental part of statistics. Samples are collected to achieve an understanding of a population because it is typically not feasible to observe all members of the population. The goal is to collect samples that provide an accurate representation of the population. Sampling design constraints on time and money dictate that the sampling effort must be efficient. More samples are needed to characterize the nature of highly variable populations than less variable populations. There are three types of sampling design. First, random sampling. Second, systematic sampling. And last, stratified sampling.
Random sampling. Simple random sampling is the basic sampling technique where we select a group of subjects for a larger group. Each individual is chosen entirely by chance and each member of the population has an equal chance of being included in the sample. Every possible sample of a given size does the same sample of selection. Simple random sampling is also referred to as random sampling, and it is the most purest and most straightforward probability sampling strategy. It is also the most popular method for choosing a sample among population for a wide range of purposes. In simple random sampling, each member of population is equally likely to be chosen as part of the sample. It has been stated that the logic behind simple random sampling is that it removes bias from the selection procedure and should result in representative samples. Ideally, the sample size of more than a few hundred is required in order to be able to apply simple random sampling in an appropriate manner. It can be argued that simple random sampling is easy to understand in theory, but difficult to perform in practice. This is because working with a large sample is not easy and it can be challenged to get a realistic sample frame. Many dissertation supervisors advise that the choice of random sampling methods due to the representatives of sample group and less room for researchers' bias compared to non-random sampling techniques. However, application of random sampling method in practice can be quite difficult due to need of complete list of relevant population members and a large sample size.
Systematic sampling. Systematic sampling is a probability sampling method where the elements are chosen from a target population by selecting a random starting point and selecting other members after a fixed sampling interval. Sampling interval is calculated by dividing the entire population size by the desired sample size. In school, while selecting the captain of sports teams, most of our coaches ask us to call out numbers such as 1 to 5, and the students with a random number decided by the coach for this instance. 3 would be called out to be the captains of different teams. It would be an unstressful selection process for both the coach as well as the players. Systematic sampling is an extended implementation of the same probability sampling technique, in which each member of the group is selected at regular periods to form a sample. There's an equal opportunity for every member of a population to be selected using the sampling technique. For instance, if a local NGO is seeking to form a systematic sample of 500 volunteers from a population of 5,000, they can select every 10th person in the population to systematically form a sample. Other probability sampling techniques like cluster sampling and stratified random sampling can be very unorganized and laborious, due to which researchers and statisticians have turned to methods like systematic sampling or simple random sampling for better sampling results. Systematic sampling consumes the least time as it requires selection of sample size and identification of starting point for this sample, which needs to be continued at regular intervals to form a sample. Steps to form a sample using the systematic sampling technique. A defined structural audience needs to be developed for the researcher to start working on the sampling aspect. The researcher in charge must figure out the ideal size of the sample. Example, how many people from the entire population to choose to be a part of the sample. The key to precise, reasonable, and practical results is a bigger size of the sample. Once the number of the sample size is decided, a number must be assigned to each and every member of the sample. The interval of this sample needs to be decided that will be the standard distance between the elements. The example mentioned above suggests that the sample interval should be 10, which is the result of the division of 5,500. The researcher needs to select these members who fit the criteria, which in this case will be 1 in 10 individuals. A number will be randomly chosen as the starting member, called R, of the sample, and this interval will be added to the random number to keep adding members in the sample. R plus I, R plus 2I, etc. will be the elements of the sample. This is an example of systematic sampling. This is the formula for systematic sampling interval. The capital N represents for the population and the small n is the sample size.
Stratified sampling. Stratified sampling is a process used in market research that involves dividing the population of interest into smaller groups, called strata. Samples are then pulled from these strata, and analysis is performed to make inferences about the greater population of interest. In order to fully understand stratified sampling, it's important to be confident in your understanding of probability sampling, which leverages random sampling techniques to create the sample. Stratified sampling is also commonly referred to as proportional sampling or total sampling. When is stratified sampling used? Number 1. A researcher's target population of interest is significantly heterogeneous. Number 2. A researcher wants to highlight specific subgroups within his or her population of interest. Number 3. A researcher wants to observe the relationship between two or more subgroups. And number 4. A researcher's goal is to create representative samples from even the smallest, most inaccessible subgroups of the population he or she is interested in. When using stratified sampling, researchers have a higher statistical precision compared to when they elect to use simple random sampling alone. This is due to the fact that the variability within the group is lower compared to the variation when dealing with the entire population at large. Thanks to the statistical precision that stratified sampling provides, a smaller sample size is required, which can ultimately save researchers time, money, and effort. How to perform stratified sampling. Step 1. Divide the population into smaller subgroups or strata based on the members' shared attributes and characteristics. Step 2. Take a random sample from each stratum in a number that is proportional to the size of the stratum. Step 3. Pull the subsets of the strata together to form a random sample. Step 4. Conduct your analysis.
Sampling design. What is sampling design? Sampling is a fundamental